Welcome to Lesson 5.4, Applying Trig Functions. Trig functions can be used to solve problems involving right triangles. Okay, I'm going to draw the first triangle here. Okay, this right triangle is going to look a little bit weird to us. This is P, R, Q. The problem says if P is 35 degrees, so we're going to write 35 in P, and it says R is 14. Opposite of capital R is little r, and it's 14. And then the problem wants us to find little q, which is opposite of the angle capital Q. Looking at this problem, if we're going to solve for Q, we actually know the hypotenuse. Even though that doesn't look like the hypotenuse, it is. It's opposite of the right angle. So, and I'm looking for next to adjacent. So I'm going to use cosine of 35 degrees, which is opposite over adjacent over hypotenuse. So adjacent is Q, and the hypotenuse is 14. In order to solve this, I need to get Q by itself, so I'm going to multiply by 14 on both sides. And when I simplify that, 14 cancels out, so Q is equal to 14, the cosine of 35 degrees. So now I put it in my calculator, and my calculator spits out the answer 11.46168. 468. 12862, and we're going to round to the nearest tenth. Let's see, that one didn't show up. So we're going to round to the nearest tenth, so that will be the 6. I'll round up to 5, so 11.5 is Q. The next example is a real-world application, so you need to turn into your book to page 299. It doesn't like me writing up that close to the top. To page 299. Okay, and let's read the real-world application here. A circus has arrived, and the roustabouts must put up the main tent in a field near town. The tab is located on the side of the tent 40 feet above the ground, and a rope is tied to the tent at this point, and then a rope is placed around the stake on the ground. If the angle that the rope makes with the level ground is 52 degrees and 15 minutes, how long is the rope? What is the different distance between the bottom of the tent and the stake? So we're going to draw a picture here, and this is the tent, and it's 40 feet tall. And here's the rope, and here's the stake, and here's the distance between the tent and the stake. I am going to label this angle right here 52 degrees and 15 minutes. Okay, then we're going to solve for the rope, and I'm going to call the rope R. We're going to set up a trig function. We know opposite, and we're looking for hypotenuse. So opposite over hypotenuse. So I'm going to use what trig function is opposite over hypotenuse, and that would be the sine function. So the sine of 52 degrees and 15 minutes is opposite over hypotenuse, 40 over r. Now this is going to take 2 steps to get rid of r. We're going to have to get r over and then bring over the sine. So this takes 2 steps when the variable is in the denominator. So I'm trying to make a circle for a dot, and it's not letting me. I don't know what the deal is. But I'm going to multiply by r on both sides. R's cancel out, and I'm left with 40 r times the sine of 52 degrees and 15 minutes. Now I need to get r by itself, so I divide by the sign of 52 and 15 minutes. The next step would be to put it in your calculator and see what you get. When I put it in the calculator, I get r is equal to 50.5887 75357, and we're going to round it to the nearest tenth, so we look at the 8 and we decide to round up, and we're going to do 50 and 50 and 6. And notice this problem's in feet because this building over here was 40 feet. This tent was 40 feet tall. So that is 50 feet. It's 50.6 feet is how big how long the rope is. Okay? We are going to erase this so that we can do the B part. Okay, I'm going to keep the triangle here because the triangle is adequate for the next problem. Alright, let's look. It says, what is the distance between the bottom of the tent and the stake? Well, the bottom of the tent, I'm going to call D for distance. So this is, what is the distance between that and the stake? Notice I would not use the previous information that I did for rope to solve this problem because if I use that and if it's wrong, then I'll make this one wrong. So I'm going to use this distance here, and I'm going to use this opposite. So I'm going to do opposite over adjacent, which is tangent. I'm going to do the tangent of 52 degrees and 15 minutes is equal to opposite, which is 40, over adjacent, which is D. This is another one of the two-step problems to get D by itself. So I'm going to multiply by D on both sides. And then I'm going to have to divide by tangent. So I'm going to divide by the tangent of 52 degrees and 15 minutes on both sides. And now D is by itself. That cancels. D is equal to 40 over the tangent of 52 degrees and 15 minutes. Now I'm going to put it in my calculator and I'm going to get an answer, which is D is equal to 30.971309111, and I'm going to round it to the nearest tenth. Okay, I look at the 9, I look behind it, I need to round up, so that's going to actually go to 31.0 feet. Alright, well now you need to tune in to the next video, video number 2. Alright, thank you.